thank you everyone for joining us. And as Raju Bhaiya said, we did a lot of hard work, all of us together, to be here. Some of us had to actually shift our schedule. I know Sunday afternoon is not always easy. So thank you everyone for being here and joining the cause for something which we can do good for the society. I will ask Neeraj to come online, show his face because we'll be introducing him. Neeraj. Neeraj Yagnik did his chemical engineering from IIT Bombay and then his management course from IIM Ahmedabad. The entrepreneur in him got the better of the managerial training, and he has been in business after a short stint in the industry. He also has spent over a decade in academics and he's interested in strategy, safety management, and social intervention. So Neeraj, over to you to start the event.
Thank you very much, friends. How you hope this session, I'm sure this session will be better than the match because that is where most people have gone off. All my friends, none of them are willing to come on line for anything else. Yeah. Well, we are at the way this session is put, and I am sure Dr. Nautiyal is in ideal. We are in ideal hands with Dr. Nautiyal. I would say that the interesting thing is to go for interstellar travel because that is where we need to find our new home. And I am sure that we will be put onto a new journey with this session. And I hope let's go on with that. Let's go for the session that we have been eagerly awaiting. Over to Dr. Nautiyal.
Dr. Nautiyal, I will invite you once again after some time. If we go by the flow, we wish to play vision video, but because of
XENA World Vision Document. We are a family bringing joy, happiness, prosperity in our lives and around by nurturing, encouraging, catalyzing, enabling 360-degree well-being in physical, intellectual, emotional, social, and economic dimensions. Our vision: abundance of joy, happiness, care, and prosperity for all. Our mission: we strive for alleviating pain, suffering, and poverty, encouraging unshackled-free thoughts, enabling dignified jobs and livelihood, nurturing close family bonding, seeking joy and happiness in the impact caused. Our values: passion, work with passion and from heart. Our values: humility, learning attitude, mutual respect, and open to listening to others. Our values: integrity, sincere, honest, and ethical principles. Our values: empathy, understand and feel others as your own. Our values: humanity, have compassion, brotherhood, fellow feeling, and kindness. Our values: joy, work that brings joy and value, diversity and inclusion. Our character: trust, belief, faith, and confidence in self and in others, from where love and compassion emanate. Our character, virtue, high moral values, patience, consideration, trustworthiness, and forgiveness. Our character, transparency, honesty, openness, and not guarded. Thank you. You have just watched a montage of some people getting together at important venues like boardrooms in beautiful locales such as well-manicured gardens and exchanging pleasantries. What does all this have to do with the activities of XENA and its vision for a better future? Actually, these are the people who work behind the scenes. They have taken time out of their work and family schedules to gather at centrally located places to discuss important issues. They did not necessarily know each other before these meetings, but they met nevertheless to present and listen to others' deeply held beliefs on how to achieve social well-being through XENA's mission and vision. These meetings typically went on for several hours. Some had a firm agenda, others were more unstructured brainstorming. In all instances, the members arrived at a consensus without any coercion or manipulation. All processes were democratic. Nobody was superior or inferior. Nobody's personal values carried the day in the end. We show these pictures of people arriving at decisions on how to move forward, what to prioritize given the urgency of certain themes and contexts, and what to avoid so that the group unity doesn't suffer. These snapshots of people exchanging flowers, posing for group shots, and exchanging information about each other are indicators of cooperative working, respectful disagreement, and newly forged alliances based on mutual respect. These memories and milestones are a commitment to our larger mission and a promise that if you decide to join one of our many working groups, you too will have a sense of meaningful participation and collaborative learning.
No, we may take it. Acha, Rajiv Bhaiya is lost again. Fine, let's go ahead with the event, and it's an honor for me to introduce Santosh Kumar ji, our first speaker. He's the Dean School of Liberal and Cultural Studies and Senior Professor, Public Policy, Politics and Governance at Admas University, Kolkata. He is an accomplished and seasoned academician with rich experience in social science, research, and teaching, with interdisciplinary liberal association with international bodies like World Bank, UNDP, ADB, etc. An MPhil and PhD alumnus of JNU Delhi, he is an awardee of UGC-sponsored Junior and Senior Research Fellow Commonwealth Fellowship at sorry, I got diverted by a call. Yes, at Chris, Department of Politics, University of Glasgow, UK. He has been in multiple roles with some of the foremost institutions like Tata Institute of Social Science, Entrepreneurship Development Institute of India, Pandit Deen Dayal Petroleum University, Flame University, and Aura University for over 2 decades. That's amazing. He developed courses and policy documents having far-reaching impact on the national policies, implementation and evaluation, especially in the domain of SDGs, human development, and governance. He has successfully initiated and implemented research projects for esteemed institutions like UGC, ICSSR, and ADB. Dr. Kumar has a membership of various societies of repute and global think tanks. Isn't that amazing? We will be listening to a brain today. He has authored books, articles, reviewed books, and edited many of them. He has delivered keynote addresses, chaired key sessions, and presented several papers in national and international seminars and conferences. We would not have had more qualified person than Dr. Santosh Kumar as keynote speaker at today's forum. So welcome Santosh ji, and we are really eager to listen to you. Over to you.
Thank you, and very good afternoon to all of you. In fact, good evening. I have been instructed to speak first in English, first in Hindi, and then switch on to English or whichever language I want to. So, दोस्तों, सम्मानित सदस्यों, शुभ संध्या। आज यहाँ हमारे साथ रहने के लिए आप सभी का धन्यवाद। मैं आपका हृदय से स्वागत करता हूँ इस शाम के संध्या, इस शाम के इस मीटिंग में। हम आप में से उन सभी लोगों का स्वागत करने में सक्षम हैं जो लंबे समय तक से हमारे साथ हैं और साथ ही जो जेना वर्ल्ड परिवार में नए आए हैं। आज के स्वागत भाषण की जिम्मेदारी देने के लिए मैं सम्मानित महसूस कर रहा हूं। यह फाउंडेशन का उद्देश्य का सही प्रतिबिंब है, जहां परिवार का प्रत्येक सदस्य को अवसर दिया जाता है। मैं यहां आपके सामने सिर्फ इसलिए हूं क्योंकि फाउंडेशन को मुझ जैसे लोगों पर भरोसा है। मुझे यह अवसर देने के लिए मैं आप सभी का धन्यवाद देता हूं। In fact, it's indeed a great honor to be amidst such an erudite family members of XENA. I'm looking forward to be hearing to our senior colleagues, Dr. Sanjay.Marale, Dr. Sanjay.Marale, and Dr. Poonam Arora. I'm definitely looking forward to be meeting you sometimes because ever since 2009, I have been practicing and I have been engaged with the liberal arts pedagogy uh, in various capacities, sometimes as a teacher, sometimes as a practitioner. I have myself been part of that liberal arts pedagogy since my education days in JNU and all. We never knew that it was liberal arts, but the way we were interconnecting the knowledge, I think in the present times, we were actually referring to that pedagogy, now andragogy, and in future, heutagogy of liberal arts, which is very fascinating. In fact, the topic which are there today, beyond the life, is there life beyond Earth and climate change and all? I think this is very fascinating to talk about these things from the liberal arts pedagogy. This is interesting, not only from the perspective of for the sake of the knowledge, but it also shows us the connectedness of the knowledge. What we are facing, what I think I have been contemplating a lot on these kind of things. So one is the factual aspect of the climate change. One is the factual aspect of is there life beyond Earth? And then there's a philosophical aspect, and both are so intertwined beautifully that one leads to the other kind of situation. Why should there be God's particle, and how God's particle is there in everything, and how the knowledge is connecting us all coming from different kind of domains. This is something which fascinates me all the more. I think when I'm talking about the XENA family, and when I'm eager to listen to all of you, I'm a policy science person. I have been working with government of Gujarat. I have worked with the government of India. I have worked with 16, 17 state governments in India. And I was working with the World Bank, the entire South Asia, some parts of Africa, some parts of Brazil. All these have been my area of intervention, area of policy work, etc., etc. And some of the policies that I have myself worked on, I see them happening every day. Within the state governments, Gujarat state government or government of Maharashtra, and all those kind of things. I think we are blessed with such kind of opportunities, and I feel myself particularly to be blessed with such kind of opportunities, because there's something that guides us to work on these kind of areas. Ma'am Arora, when I was working with the pedagogy of the liberal arts, I was faced with several set of models. I have myself worked with the Flame University, some parts of Ashoka University on Lien, and right now I'm trying to create a pedagogy or a kind of framework of liberal arts in this university myself, and I'm looking forward to your guidance to me. When I'm doing all these kind of things, I feel that there's something which is beyond us, which is carrying us towards, which is bringing us towards these kind of events which are happening in our lives. Past few months in our lives, particularly, ever since 2020 March, we all have faced challenges. I have suffered personal losses in terms of loss of my parents, both my parents, and there's so many things happening. But there's something which is making us stronger day by day. And I believe that is very important. I think there are two things to look at in this particular situation. One is the kind of strength that we have been born, we have grown up with. That is our strength of knowledge, the strength of the institutions. And the second thing is more important, that there's something which gives us strength otherwise also, that we have to face the situation all the times. I believe this is very important at this point of times when we are faced with a crisis situation, and this is not yet over anytime soon. I believe connectedness with each other on virtual platform, and I just hope that we all meet sometime someday, and I'll be very happy to host you all on my campus in Kolkata. It's a beautiful 120-acre campus, and I'll be very happy to host you all here. But you know, this connectedness with each other is giving us so much of strength, and I'm really grateful to Rajiv ji for providing me with this particular kind of platform. When he said that, Bhaiya, why don't you become part of this whole with this whole movement called XENA? I was, you know, initially I did not have any idea about what we were talking about, but later on we got to know that basically we were talking about nothing but the synergies that we bring in. You know, the strength that we get, we come with to each other, and that is very important. I believe this is the time when we have got the strength of each other. I'm sure, you know, I'm going to be inviting Dr. Sanjay.Marale ji to give a lecture to my students. I'm sure someday I'm going to be talking to Dr. Sanjay.Marale to give us lecture to my students. I'm sure the MC for the evening, Ms. Jain Shaw, I'm going to be inviting her to talk to my students about entrepreneurship. And I'm sure I'm going to be interacting to many more such people, right? Now, this is the strength, I think, which keeps us going. And this is very important, particularly in the times of crisis. The civilizations have survived the stresses only because of this hand-holding. And I think this is the crux of what exactly is going on. I teach a paper called Ethics, and I'm also a member of Union Public Service Commission, where we have designed this paper called Ethics and Governance. I think the philosophical foundation of ethics is much beyond the civil services or anything else. That is something which is the foundation of our existence. But this is another very important aspect of us which binds us together. I could have gone on and on, but I think I'll be personally more keen on listening to our guests, Dr. Nautiyal and Dr. Marale. But before that, I'll be failing in my duty if I do not introduce the MC for this evening, Ms. Jain Shaw. And please allow me to say a few words of her. And thank you, Ms. Jain, for such encouraging words of introduction for me. Friends, please allow me to introduce Ms. Jain. Now, as you know, it's actually a proud privilege for me to speak these words for you. Jain Shaw is a business consultant and a financial strategist. She is helping startups, small to medium family-run businesses to generate growth and profits by redesigning their financial strategies. As founder of Zone CFO, she helps business managers their entire financial functions by acting as their outsourced CFOs. An experienced team of financial experts take over the entire workflow of our business, and that helps us grow our profits while we get more time to focus on the core business activities. She has 18 plus years of experience, and she has been conducting seminars, coaching programs, and consultations for business owners for more than a decade and a half. She has created 150 plus business plans and trained 1,000 plus founders and CEOs of various businesses on financial strategies, growth, and profit engineering. She is immensely passionate about financial literacy, freedom for women, and regularly appears on TV and other media platforms sharing her vision and experience. Her signature program, Honey, It's All About Money. The name is so fabulous, you know, it's so catchy. I really love the idea of this name itself, you know, Honey, It's All About Money. And we have been philosophically saying that what's there in the money. but it's all about money actually, is apt for corporate as learning and development drive for the topic of financial literacy. With these words, I invite you, Ms. Jane, to carry on with the program for the evening. And I'm particularly looking forward to be hearing to both the guests for this evening. And I'm at the end, I feel so honored to be amidst you all. A very good evening ahead, and please let's all enjoy. Let's all get enlightened by the two very erudite speakers that we have this evening for us. Thank you so much.
Thank you so much, Santoshi. Your thoughts about the topic has really put us a step further for the event. And thank you for the introduction. So are we all waiting now for the main event? Yes. So let me introduce this both speakers in a very unique way. I'm sure you are going to love this introduction. This is new way to introduce. I hope it's clear.
Let me introduce to all of you.
You can hear?
Dr. Chandramohan Nautiyal. Dr. Chandramohan Nautiyal is a well-known scientist and a science communicator. After BSc Honors in Physics from Meerut and MSc Physics from University of Roorkee, now IIT Roorkee, he completed PhD at PRL Ahmedabad, that is Physical Research Laboratory Ahmedabad. He was a scientific collaborator for the study of lunar samples brought during Apollo and Luna missions. He is Fellow of Geological Society of India, NCSTC Network, that is National Council for Science and Technology Communication Network, and Social Earth Scientists. In addition to INSA Medal, that is Indian National Science Academy Medal for Young Scientist 88, Travel Award from Meteorological Society USA, and INSA DFG Fellowship. DFG is basically German Research Foundation. He is a recipient of about a dozen other honors and awards. He has been member of many science committees, including National Commission Archaeological Sciences, and was a convener of NCSTC Network. Superannuated from Sani Institute of Paleo Sciences, Lucknow, which is an institution of the Department of Science and Technology. In 2016, as scientist in charge of radiocarbon laboratory. On invitation, he has visited many countries, including France, UK, USA, Germany, Switzerland, South Africa, Russia, and Vietnam. At present, he is consultant, science communication to Indian National Science Academy, that is INSA, New Delhi. He is also member, Board of Studies, Chaudhary Charan Singh University, Meerut, Vice President Vibha, Chairman, NCSC UP. NCSC is National Children Science Congress. Member, Local Advisory Committee, RSC, Lucknow. Management Committee, MR Jaipuria College and Indus Valley School, Lucknow. Advisor, Breakthrough Science Society, Kolkata, UP chapter. Chairperson, NCSC UP East. Member Executive, Vigyan Parishad Prayag as via Andraki. Club of Lucknow. Vice President, Bharatiya Bhasha Pratishthapan Rashtriya Parishad UP. He is also a member of the Publication Committee, Vigyan Prasad, a DST institution, and member of American Association Advanced Science, USA. PSCT network, that is Public Commission of Science and Technology, and corresponding member Palcom, Switzerland. We at this forum are honored to have him as a speaker.
Amazing. Let's have another introduction also. Dr. Sanjay.
Let me introduce to all of you Dr. Sanjay.Marale. Dr. Marale is an assistant professor at Kamla Nehru College, University of Delhi for last over 6 years. He teaches environmental science to the undergraduate students under Choice-Based Credit System, CBCS, of UG. He is the president of Society for Environment and Sustainable Development, a pan-India forum. Dr. Marale's high school was a 2-kilometer journey from his village, to which he had no other option than to be on foot. He completed his degree in chemistry, that is BSc, from ASC College, Palus. And yet again, he showed his enthusiasm towards his study by paddling a bicycle 15 kilometers to and from his college for all the 3 years. He finished his master's degree in environmental science from Shivaji University, Kolhapur in the year 2000. Having completed his PhD from University of Pune in 2012, he is also a research assistant at Society of Integrated Coastal Management since October 2010 till date. We at this forum are honored to have him as a speaker.
What an amazing both the speakers that we have. Clap for them. And मुझे ऐसे लग रहा था जैसे हम कौन बनेगा करोड़पति में हैं और अमिताभ बच्चन जी आप दोनों को इंट्रोड्यूस कर रहे हैं. राजीव भैया, this is a super way of introducing our speakers. So, without waiting further, may I request Sanjay ji to take the session ahead. Over to you, Sanjay ji.
Okay, thank you. Thank you. And good evening, all of you. Am I audible? Okay, thank you. So the presentation, can I show the presentation that facilities are available?
Sanjay ji, sorry, but we don't have presentation option available because host option is not available. So we would rather see you than see the presentation this time.
Okay, no problem. I prepared one small presentation, but anyways, it is with me on my mobile. The topic is climate change and freshwater replacement, major challenges and solutions. This is my topic. Then I'll be speaking about climate change. Basically, I would like to throw light on the a survey, international survey, which is being carried by United Nations. And there are about 13 to 14 questions which are asked for all the participants which take this survey. And they are participants are asked, this is online survey, and participants are asked to mark their priorities on the answer. And climate change is one of that. And besides this climate change, energy, clean energy, then employment opportunities, and social protection, and all these options are there. But when we see climate change, it comes on the last side. Means this issue is not top priority in any of the country, including India. Now, what is the priority of Indians? On that survey, if you see, it is online and all the details are available. This priority of the Indians is job opportunities. Whereas any other countries results also, if you see, this is not the priority. Climate change is not a major priority because they are most of the people are worried about education and other issues, but climate change is not given importance in this case. When we are talking about climate change, there are so many aspects, and when we try to understand climate change, we must understand it in a bigger picture of sustainable development goals. I guess Dr. Chandra sir, Chandra Nautiyal sir, and Dr. Santosh Kumar sir earlier well said about the sustainable development goals. In short, they have briefly told us about sustainable development goals. And Society for Environment and Sustainable Development in Delhi, which is in Delhi, we are working on the sustainable development goals. This is a small organization we recently started, but our basic aim is to help the global community to achieve these sustainable development goals. And since this is a very bigger task, we are trying to give justice from our side, because since the basic motto or idea of the sustainable development goals is no one should be left behind. It is the agenda itself is driven by the idea that no one should be left behind. And when we are saying no one should be left behind, a lot of energy, time, and resources are required to bring all people in that stream of sustainable development goals. First, one thing is very important, that all people should know about sustainable development goals. And secondly, what kind of actions are required to achieve these sustainable development goals? That is very important. But again, when we see sustainable development goals across the globe, many surveys are carried out, and 99% people are not aware about sustainable development goals. This is the reality. In case of India, this is also the same thing. Hardly 1 or 2% people are aware about sustainable development or sustainable development goals. There are people, many people are aware about the word development, but not sustainable development or sustainable development goals, which is part of the Agenda 2030, which contains 17 goals, 169 targets, and 232 indicators to measure the progress on sustainable development goals. Out of that, one important goal is climate action. Goal number 12 is climate action. And within that, there are so many targets and indicators to measure the progress. And when we'll see in 2021, this year only, United Nations has published its report, Sustainable Development Goals Report 2021. And for each indicator, some data is provided. There are about, as I said, 232 indicators are available. There are about you can say 20 indicators which are specified for the climate change. But you will see the report, the data is not available. And the United Nations has collected data for various regions. For example, Europe and North America, Sub-Saharan Africa, then Southern Asia, Eastern Asia, likewise. All over there are about 21 regions, regions and sub-regions. But if you see major regions, these are 8 regions for which the data is collected. But you will see specifically, you will see the data related to climate change, data is not available. Why is it so? Because United Nations and so many organizations are working for a very long time, but why data related to climate change is not available? And one more important point is sustainable development goals. The other sustainable development goals for which data is available, but what I guess United Nations or some of the powerful forces are trying to hide the data which is related to climate change. Why is it so? Because, and the result is you can see the COVID-19 mortality rate in Europe and North America, it is very high. And you will see overall score on sustainable development goals of the regions, Europe and United States of America is number 1, because they have done better progress on all sustainable development goals. But for some indicators related to environment and climate change, data is not available for any region. Then why there are number of organizations, sister organizations of United Nations, and it is responsibility of all these organizations to place the data for all the parameters which are prescribed in the Agenda 2030. But some of these parameters are easily skipped. So what I mean to say, climate change, the biggest problem or biggest contributor of climate change or greenhouse gases is United States of America and Europe. These are the countries which are major contributors. And if you see the COVID-19 mortality, these are the countries which are highly affected. More number of mortality, COVID-19 mortality we can see in Europe and Northern America. So, and what are these factors? One is very important, is greenhouse gases, which ultimately results into climate change. And secondly, the ecosystems. It could be aquatic ecosystems, or it could be terrestrial ecosystems. But these ecosystems are highly affected and converted into the situation. But since we don't have data, I guess I'm very sure that because these countries are very developed countries, they have enough economic resources, they can maintain their resources and ecosystems. But something is wrong. Otherwise, the COVID-19 situation, there are some geographical factors also because of which COVID-19 situation got worse in these countries. But especially greenhouse gases and climate change has to be taken into consideration seriously. In case of India also, climate change, the greenhouse gases, contribution of greenhouse gases in India is also increasing. China and other countries is increasing, but these countries are far ahead of us, and our contribution is, in comparison to them, is negligible. And my topic today is its impact on the aquatic ecosystems. Freshwater ecosystems are one of the diversified and important ecosystems of the earth. It includes ponds, lakes, streams, rivers, and wetlands. Ponds, smaller aquatic bodies with stagnant water, we all know, lakes, streams, rivers, and wetlands. The wetlands, this is the concept of the wetland is very important. Perennial or seasonal areas covered or saturated with water, promoting both terrestrial and aquatic biodiversity. These can be saline, these could be in the saline areas or freshwater areas, and divided into two parts. Features of freshwater ecosystems, biotic factors and other factors are there. Then I'll just go ahead. Major issues, I'll just come to this important point: nutrient loading, biodegradable and non-biodegradable pollutants, pesticides, heavy metals, plastics, chemical elements, nitrogen, phosphorus, etc. are accumulated in the nearby freshwater aquatic bodies via domestic sewage, agricultural runoff, hot industrial wastes, etc., driving the water chemistry alteration of the aquatic body due to acidification. So this important, see, because of climate change, water bodies are affected in many cases because of high water evaporation. And secondly, very important one is nutrient loading. Earlier, people used to use very less resources in the form of soap, and usually they will be having different kind of toilet facilities, like local toilet facilities, where they will not discharge their waste into water bodies. But now all the urban areas are connected with this sewage system, and all this waste goes to the water bodies directly into water bodies. Then that results into nutrient loading. That is becoming a major issue. In case of Delhi, people say all people are taking water from Yamuna River, and 99 to 100% population again release the wastewater into the same river. That is the major problem. So they do not want to think about the people who are living downstream. And once we are discharging that much amount of waste, it contains a lot of nutrients, we all know, and that has very negative impact on the water quality as well as overall aquatic ecosystem, its structure and function. So many effects will be there. Then disproportionate amount of nutrients leads to the stress situation for the living organisms of the freshwater ecosystem, especially primary producers, algae, microphytes, and plants, which cannot withstand after a certain level. The aquatic organisms either emphasize to survive rather than its reproduction, or migrate to any other suitable habitat. So this will be the fate of the organisms. Eutrophication leads to dense and harmful algal growth on the surface water. This does not allow the light penetration properly and uses the dissolved oxygen from water, increasing the biological oxygen demand of the aquatic systems. Those blooms can also release many toxic chemicals. The intrusiveness of the more tolerant, invasive, and alien species gradually substitute the native community structure and composition, decreases the species richness of that ecosystem. These are some of the important points, and temperature is one of the very important. Why is it so? Because of already climate change, many temperature is rising, and because many industries release very hot water into these ecosystems, conditions for the aquatic biodiversity, leading to the disruption in their physiological metabolism. A warmer environment fosters to melt of the icebergs and glaciers, resulting in the sea level rise, thus wetlands and biodiversity loss. The evapotranspiration rate is positively proportionate with the temperature. Higher amount of water loss also hinders the biodiversity preservation in the freshwater ecosystems. So what can be done in this case? Should be given towards evaluation.
Sanjay, your voice is breaking. We can't hear you.
The concentration should be. Hello. Am I audible? Hello.
The voice is lagging.
Yes.
Your voice is lagging.
Hello. Am I audible?
You can continue. As of now, it's not clear.
Your voice is lagging.
Hello. Okay. Hello.
Yeah,
Am I audible?
This is much better. This is much better.
Okay. Then another one is the concentration should be centered more on filtration before discharging it in the fresh water to mitigate the nutrient loading of excess materials and non-biodegradable objects in that ecosystem. So filtration is suggested. Filtration, what happens? Such a large amount of nutrients are already there, and besides nutrients, there are some other components. Pesticides are there, chemicals are there, and plastic is also there in that sewage water, wastewater. So if all of that will carry into water body, the overall oxygen demand of that aquatic ecosystem will rise, and eventually all the organisms will die instead. In case of India, 90% or more than 90% of the sewage systems are not working properly. Sewage is discharged into water bodies without any treatment. That is the reality. And this is not only for India. All over the world, if you see the sewage treatment plant and its efficiency, it is only 80, it is only 20%, 80% without any treatment. So we have to work on that one. Or there is one more option. I'm sorry to say, it should be followed like a dictatorship. In the sense, those people who are generating waste, it could be wastewater or it could be solid waste or it be water, you can say. It is their responsibility, it is responsibility of each and every family to treat their waste. If that will follow, certainly the problem will be solved, but it is not possible because now 95% population are dependent on the, you can say, government for treating their waste. Those people who are living in the rural areas only, they are not dependent on their, are not dependent on government for treating their waste. So this option is available. For that, we need to restructure the urban areas, and there should be some policy interventions by which people should be asked, people should be, you can say, people should be asked to treat their own waste. If that will be followed, certainly this problem will be solved. But this is not a problem of one particular community, one particular village, or one particular country. It is all over world, not only in India. Sewage is discharged in other countries, also in other water bodies. Solid waste is a major problem. So these problems need to be a better policy intervention. And once we have that one, at least people need to understand this one. And people understand only one thing, that they need to minimize the waste. But even though we are minimizing the waste, overall, as the population is increasing and number of people are migrating towards urban areas, overall waste production is increasing. So we need to think about that very important aspect. And not only nutrient loading and other issues, but these sewage also contribute to greenhouse gases, because it releases large amount of gases which are also toxic and which are also greenhouse gases. So we need to think about these issues in a holistic manner. So Sustainable Development Goals framework give justice to all of these issues: economic, social inclusion, and environment. Not only climate change, but in case of environment, there are other issues also which are related to environment. So when we are thinking about environment, we need to think into the bigger picture of sustainable development or sustainability. And Sustainable Development Goals is the very great idea, I can say, we should follow. And under that umbrella, there is a large scope for all people, all enthusiasts, all experts and activists to come together and work towards better future, our better future. Thank you. So this is my point of view on the climate change and sustainable development goals. Thank you very much.
Thank you so much, Sanjay ji. We'll have question and answer for you once we have another speaker with us. So once Dr. Chandra also speak to us, we'll have question and answer session. So Dr. Chandra, over to you to take this ahead. Please unmute yourself. Unmute yourself.
Yeah. Am I
Yes.
audible now?
Now you are audible. Yes, please go ahead.
Thank you, Professor Santosh and Jane, for a very kind introduction, and Mr. Rajiv for inviting, and Colonel B.D. Singh for a fantastic way of introducing us. I'm going to be like a Madari in the Madari, you know, on the roadside. He claims that he is going to cut a person in two halves, and he keeps on saying it, but never does that. So similarly, when I am going to talk to you about life beyond Earth, the end may be a bit of antithesis in the sense that we have not really encountered any life form anywhere in any place other than the Earth. So in that way, it's going to be a little bit of disappointment. But let us go and explore. Why should we expect life on Earth? Where do we look for possible signatures of life? And where actually life is possible within this solar system or beyond it. Many years ago, Werner von Braun had asked a very pertinent question. He said, our sun is one of the 100 billion or so stars in our galaxy. Our galaxy is one of billions of galaxies populating the universe. It would be height of presumption to think that we are the only living things in this enormous city. Now, this is something which makes us think that really, when there are so many stars in each galaxy and so many galaxies, then why should we ever think that we should be the only living beings in this universe? 500 years before Christ, Socrates has said, humanity must rise above the earth to the top of the atmosphere and beyond. And only then will we fully understand the world in which we live. And this is indeed true. We cannot understand this earth unless we go beyond this earth, above the earth, and look at it as a stranger or as somebody who is not a part of this earth. So within our solar system, if we consider the planets, now we know that there are 8 planets in our solar system. Sun is not a planet, it's a star. And the 9th planet, which was a part of our solar system, is now out of it, which is Pluto. For many reasons, I will not go into that. It was a technical decision. And we have only 7 more planets and our own Earth. Where on these planets should we expect any kind of life? May I request people to please switch off their mics? So what I'll try to do is, of course, it would be great if I could show you the visuals, but since that is not possible, I'll only manage with a little bit of description. But before that, we must ask a question. Why don't we see if there are any extraterrestrial life forms? Carl Sagan, the famous planetary scientist and science popularizer, had said, civilizations either became spacefaring or they became extinct. Or maybe they're not advanced enough to approach us. Or maybe we are not advanced enough and we don't interest them at all. They're not interested in coming to us or visiting us. Or maybe we are not just capable of detecting the signals that they may be sending. All these possibilities are there. So as far as the Earth is concerned, you would notice that the life on Earth is a result of too many coincidences. Earth has got water, which was not there in the very early stage. But once Earth got water, you know that this is a place where ultraviolet radiations won't reach. And we know that ultraviolet radiation can damage the nascent or the very young forms of life. Initially, when there was no ozone layer over Earth, all the sun's radiation, particularly in the early stages, there was a lot of radiations coming from the sun on Earth, and all that radiation would have killed if there were any form of life on Earth. But fortunately, Earth developed oceans, or maybe some pools of water, and inside those pools of water, if life originated, it could survive. It was protected from the ultraviolet radiation. Another factor was that Earth was pretty huge. Therefore, the gravitational force of Earth was able to hold the atmosphere to itself. If Earth were smaller in size, the gravity wouldn't be able to hold on to the atmosphere, and all the molecules of the atmosphere would have escaped. But Earth was heavy enough, and it had an atmosphere. Now, because of atmosphere, there was another very interesting thing, and that was the cosmic ray particles, the very high energy cosmic ray particles, which are constantly bombarding Earth and all other planetary bodies. They could not reach the Earth's surface and damage us. These energetic particles have so much of energy that we have not been able to produce such energetic particles in any laboratory in the world. They have energies of TeV, energies of billion electron volts, energies of thousands of billion electron volts, and if they could bombard Earth, any form of life here would have been wiped off. In addition, Earth has got a magnetic field. Now, what the magnetic field means is that the charged particles which are coming from outside, they do not reach us. Instead, they are diverted towards the poles, and we are protected from these charged particles which could have damaged us. In addition, there is a pressure of the atmosphere. Now, what this means is that, as you know, that water boils faster if there is no air pressure. For example, water boils much faster on a mountain than at the sea surface. And this is because there the air pressure is low. Now, Earth has got atmosphere, therefore, it was able to retain its water, whereas those planets which did not have an atmosphere were not able to contain water on their surface. And now look at some other very interesting coincidences. We have water on Earth in liquid form, water, it flows everywhere. We have it in solid form as ice, and we also have it as vapor in the atmosphere. Now, this makes things very easy. For example, if there is water, there can be solutions and the chemical reactions can take place. On planets which are far away from the sun, such as Saturn, the water can only be frozen. It cannot be there as liquid, and therefore many things which are necessary for our life won't take place. Similarly, the bodies which are very close to the sun, such as Venus or Mercury, there the temperature is so high, something like 450 degrees Celsius. At that temperature, water cannot sustain because water boils off at 100 degrees Celsius, which means if there were any water there, it would have escaped into space long ago. We would be having, if Earth were closer to sun, we would be having Earth where there would be no water, and no water means we cannot survive. In addition, Earth rotates in 24 hours. Earth makes a circle of sun in 365.25 approximately days. Now, neither this speed nor this rotation is so fast that we cannot sustain on Earth. If Earth were rotating very fast, such as Mercury, there could have been 2 strong winds, and it would be very difficult to survive on this Earth because of these strong winds. Now, another beautiful coincidence is that Earth is at a right temperature from sun. Now, you see the temperature that we have usually on Earth is around, on an average, 17 degrees Celsius. In India, we have temperatures like sub-zero, and then it goes up to 40 or 50 degrees Celsius. So there are places where it's all the time sub-zero. There are places where it's all the time about 30, 40 degrees Celsius, and even go as high as 58 degrees Celsius. But even at these temperatures, our blood doesn't boil. Water doesn't boil off, and therefore life is possible on Earth. And why we survived here is also because initially, like Venus, Earth also had a lot of carbon dioxide in its atmosphere, but we had water. This water caused rains, and because of this hydrological cycle, the rain was able to wash down the carbon dioxide, and this carbon dioxide formed carbonates, and these carbonates were washed off into the ocean. Therefore, a lot of carbon dioxide which was in the atmosphere got buried in the ocean, either as carbonates or it was dissolved in the ocean. Now imagine a situation which Dr. Marale just warned. We are observing a changing climate. If the temperature goes on increasing, and if the temperature of the ocean goes on increasing, a stage will come when ocean will not be able to absorb any more carbon dioxide from the atmosphere. The result would be the air would be toxic. We would not be able to breathe into this air. Perhaps we have to resort to some kind of purifier constantly, which we will have to carry on our backs so that we could breathe. And we know that in cities like Delhi, the pollution has really made things worse, which Dr. Sanjay just warned about. Things on Earth are such that it's a fortuitous, it's a combination of so many coincidences, the right distance, therefore the right temperature, and therefore presence of water, slow rotation, slow revolution. All these things made conditions suitable for life possible on Earth. And on top of that, Earth has got hydrogen, Earth has got iron, Earth has got carbon, Earth has got nitrogen, Earth has got phosphorus, and many such elements which are required to make a cell. And we know that our body is made of cells. If we did not have these elements on Earth, cells wouldn't have formed, the bacteria wouldn't have formed, and then multicellular bacteria wouldn't have formed, and the life wouldn't have evolved in the way we have seen it on Earth. So why do we say that life is difficult on some other places? Because if we want life to evolve, life to originate and evolve and survive on any place, there should be essential raw material which can make protein. And which means they should be able to make amino acids. Those amino acids will make protein, and those proteins will be responsible for making cells, and ultimately those cells will evolve into more complex creatures like human body. You should also have a stable land mass which is not at a very high temperature. If there were lava flowing on the Earth's surface all the time, we wouldn't be able to survive on Earth. We should also have protection from ultraviolet, the cosmic rays. We should also be protected by an atmosphere, because if you go to the surface of moon, as you would have seen the photographs of the grains and rocks from the moon surface, I analyzed them for my PhD, so I know that you see a lot of pits there, you see a lot of craters on the moon surface. Now, if Earth didn't have atmosphere, the same kind of bombardment would have killed any form of life on Earth. But we are protected because of our atmosphere. So the atmosphere doesn't just give us oxygen to breathe, it also protects us from cosmic ray particles, and it also protects us from those asteroid or meteoritic bodies which are bombarding every planet coming from the space. We have carbon, nitrogen, phosphorus, iron, all these oxygen, all these elements which made it possible to make human body. Now, in this our solar system, if we start traveling from the sun, where do we look for life? If we go close to our Earth, it's the moon, and moon, as you know, daytime temperature is boiling. It's 100 degrees Celsius or so. And during the night time, the temperature goes maybe 50 to 100 degrees below zero. Therefore, it's very difficult for any of us to survive on moon. Moon doesn't have water on the surface, but as you know that Indian scientists have found out that under the surface, there is water on moon. In addition, there are cracks on moon surface, and inside those cracks, there is frozen ice. And the ice is frozen there. It doesn't ever evaporate because they are so deep that sunlight cannot penetrate to reach those depths. Therefore, there is water inside the moon, and people thought that maybe sometime we would be able to see some primitive form of life either inside those cracks or under the moon's surface. But so far, we have not found. If you start from the sun, the planet which comes first is Mercury, which is about moon in size. This is very reflective, but this rotates very fast. But another peculiar feature is that its temperature on the surface during daytime is approximately 450 degrees Celsius. And we know that even water boils off at 100 degrees Celsius. So it's not possible for any living being to survive on the surface of Mercury. And during nighttime, the temperature goes as low as minus 183 degrees Celsius. So you know that it's a very, very difficult condition, and we cannot expect life to be there. Now, the next planet, as we move away from the Mercury, is Venus or Shukra. You may have seen Venus sometimes as a very, very bright object in the evening sky or in the early morning sky. It's so bright that people used to call it morning star or evening star. And people say that when it's very bright and atmosphere is clear, sometimes even a shadow can be cast because of the light from Venus. So Venus, as the name suggests, is not like that. Venus brings to us mind of a very beautiful person. And Venus, you know that in the Greek mythology, Venus means a very beautiful lady. But Venus actually is toxic, as they say, that the beauty can sometimes be toxic. Venus is clouded in ammonia, in methane, in carbon dioxide envelope. If you go to the Venus surface, you would see that there is sulfuric acid droplets in the atmosphere of Venus. So it's obvious that no form of life can survive close to in that kind of atmosphere. And the temperature on the surface of Venus is more than 460 degrees Celsius. Now, those of you who are very curious would have noticed that Venus is farther from the sun, but the temperature of Venus is more than Mercury. Now, this is something intriguing, and the answer is very simple. Venus has got atmosphere, whereas Mercury doesn't have any atmosphere. Therefore, Mercury does not trap any heat. Whatever heat it receives during the daytime, it escapes during the nighttime. There is no atmosphere to block that. In case of Venus, there are a lot of greenhouse gases in its atmosphere, be it methane, be it carbon dioxide. All these gases trap the gas, and therefore the temperature of Venus is higher than Mercury, even though this is farther away from the sun. The distance from the sun is about 11 crore kilometers, and this is about 4 crore kilometers from Earth. But still we see it as a very bright object. And that is because of its reflecting atmosphere. Now, if you further go, there is Earth, and if you go beyond Earth, away from the sun, you have the fiery Mars. Mars can be seen in the sky as a slightly reddish object. That is because there are a lot of metals there, and iron there is oxidized, which suggests that there was oxygen in the atmosphere of Mars some time back. But today, in atmosphere of Mars, all you have is a little bit of carbon dioxide. Practically no atmosphere, only a little bit of carbon dioxide, and even a little methane has been detected, even from Earth. From using some infrared telescope, it has been detected that there is some little amount of methane in the Martian atmosphere. But do we have air there? Do we have winds there? Do we have organic material there? These are the questions people are probing. But Mars has always interested humankind. There was an Italian astronomer by name Schiaparelli in Milan, in Italy, and he said he was a very keen observer. He was an amateur astronomer. He used to look at Mars and draw the diagrams. And he said that there are canali on the surface of Mars. What he meant was that there were channels on the surface of Mars. Now, channels is called canali in Italian. And when he said canali, the English-speaking people thought that what he meant was canal. So if there are canals or nahr on Mars, obviously they must have been built by some living being, some intelligent people. And so the myth got a strength that there was life on Mars. In fact, there was a movie made on this theme, that there could be life on Mars. There are a lot of science fiction movies in America where they say that people from Mars came and invaded Earth. Now, the question is, can we really have a life on Mars? I'll come to this question after a few minutes. But I must tell you that beyond Mars, before Jupiter, there is a belt of solid bodies which are orbiting Earth. These solid bodies are called asteroids, and they have very interesting structure. In fact, one of them has been, which is the size is not very huge, it's about 140 kilometers. And this asteroid is supposed to be made purely of iron and nickel. In fact, some people say that there could even be asteroids which are made of more precious material. But if this is made of iron and nickel, so given the price of nickel, its price, the price of this asteroid has been estimated to be something like 10,000 quadrillion, thousands and thousands of $1 billion. Of course, the new question, who goes and brings that back to Earth? If you go beyond this asteroid, there is this grand boy of the solar system, Jupiter. Jupiter is the big, is a very, very huge planet, the biggest, and it's more than 300 times Earth. But again, this has got obnoxious gases in its atmosphere. It has perhaps sulfur. It also has some sort of heat inside its body, and this continues to remain a riddle. What generates its heat? Because it dissipates more heat than it receives. But then the conditions here are again not favorable for life. This has got a lot of satellites like Ganymede, Callisto, Io, and Europa. Some of them are active. There are volcanic eruptions there, which give away a lot of sulfur dioxide and methane and such obnoxious gases. Satellite like Europa, where people say under the surface there is a huge lake. And if there is a lake there whose temperature, suppose, is not very low, then people believe that there could be life in this satellite of Jupiter, which is called Europa. If you go beyond Jupiter, there is a planet Uranus, which has got an atmosphere. This is the third largest planet in our solar system, very huge, more than 50,000 kilometers in diameter. And this takes 84 Earth years to orbit Earth, and it rotates, well, medium scheme slightly faster than Earth. It has got many moons, many satellites. Now, it has got in atmosphere gases like hydrogen. So this also cannot support life. People have gone to Saturn, which is the next planet beyond that, and they have even gone close to its satellite, which is known as Titan. But when we say close in astronomical terms, this means millions of kilometers. So what the people did was they sent a spacecraft, and that aircraft was in 2005. That aircraft dropped a probe, an instrument on the surface of Titan, which is a planet of Saturn, which is a satellite of planet Saturn, and it fell through its atmosphere, and it gave us a lot of information, which meant that it rains there, but this is not raining water. This is raining methane. The surface could be soft. There are winds, there are lightning, and there are storms, and there are gases which are vicious, and therefore one should not expect life to be there on Titan or on Saturn. And in any case, Saturn again has, it's a frozen satellite, it's an icy satellite, so it's very difficult to expect the kind of life we are familiar with. So Titan's surface is not even. There are small hills there. This is very rugged surface, and there are craters there, meaning that planet must be bombarded by, and also some people have found some evidence of mysterious oily flows of cryogenic ice on that surface. And the temperature there is something like 200 degrees Celsius below zero. So again, these conditions are not favorable. Now, the last hope remains was Neptune, but whatever properties we have on Neptune, it was discovered long back in 1846. And it's again 50,000 kilometers in diameter, so a very huge planet. But again, its atmosphere is having hydrogen and some helium. Therefore, we don't expect that anybody could breathe on this planet. The temperature is again very low, again hundreds of degrees Celsius below zero. That means within our solar system, there are probably no planets where life is possible. But people suspect that there are some satellites like Enceladus, which is a satellite of Saturn. And when photographs were taken from a faraway place, then they observed that this was 500 kilometers in size. But the lower hemisphere, the lower half of this satellite Enceladus, was spraying water which was warmer than the general surrounding there. And it contained silica nanoparticles, ice particles, and they were moving out with a velocity of 400 meters per second. Some of these particles went back, some of these particles reached the ring of Saturn and became a part of that. But then this is a place where people think that life could be possible. But there is no definitive evidence. So after this exploration of ours of the solar system, we can say that the chances are very remote that we would find evidence of life within the solar system other than Earth. But then, could we find some other life forms? Because we know that there are asteroids in the solar system. There are comets which come from faraway places. Then sometimes what happens is these asteroids, which are orbiting Earth between the orbits of Mars and Jupiter, keep colliding with each other, and some part of it falls on Earth. We know that the Earth is orbiting around the sun, and in the process, sometimes it comes across a chunk of this asteroid, captures it because of gravity, it falls to the Earth's atmosphere. If this happens to be a small particle, which happens many times, we see them in the sky, in the atmosphere during nighttime as meteor, as a phenomena of burning grains, burning particles. But then most of them come because of comets. When comets are icy bodies, they come from thousands of astronomical units. And when they come close to Earth, they start disintegrating because they have a nucleus, a solid body in the center, not in the center, almost at the end. And this disintegrates because it fragments because of the temperature increase because of sun. And those fragments sometimes are captured by our Earth due to gravity. And when they fall through the atmosphere, those small particles sometimes appear in the night as meteor showers. In the month of August, in the month of December, you see them as meteor showers every year because these comets come close to Earth periodically, say every 88 years or every few years or every 100 years or every few thousand years. Now, inside this comet, people hope that sometime we will find a small piece reaching Earth, and inside that we will find some form of life. Similarly, the bodies which I termed as meteorites, which I termed as asteroids, they come to Earth as meteorite, as solid chunks. They could be stony meteorites, they could be rich in carbon, they could be almost pure nickel and iron, they could be a mix of stone and iron. These bodies reach Earth's surface, they are recovered, they're put in the museum. For example, in our country, any such asteroid becomes property of Government of India, so it goes to Geological Survey of India, and this goes through different laboratories for studies also. Inside these bodies, sometimes it's possible that when we break it open, inside we will find some bacteria or some evidence of life which existed maybe lakhs of years ago. And these meteorites keep coming. And there are cases where one Mr. Reddy in the United States in New Jersey, his house roof was broken and a stone that is a meteorite fell there. Once in India, we have had many such meteorite falls. We have had them in Rajasthan, in Meerut, in Assam, in another place.
Chandra,
Yeah.
Just sorry to interrupt you, but you are taking such an interesting topic. And now we have an option for screen sharing. So if you wish, we can start.
Okay. Oh, thanks so much. I'll just share the screen. So I should go to share screen. Host disabled participant screen sharing.
Fine. Arundhati ji, please make him the host so he can share. Okay.
So should I share the screen now?
Well, are you able to share?
No, not yet. It says host disabled.
Fine. Let me sort this out again and come back to you. Sorry to interrupt.
Okay. How much time do I have now? 10 minutes?
Yes, we have.
Okay. Fine. So these meteorites keep falling on Earth from either asteroidal belt or from the comets. In fact, sometimes these bodies that fall on Earth come from Moon and also Mars. If you remember, some of you would remember that in 1997 or so, Mr. Bill Clinton was on the screen, and for a change, for an interest and a scientifically interesting subject, and that was American scientists had found a meteorite in the Arctic area, in the polar area. They brought it to the laboratory, and when they studied it, they found that there was something inside them which appeared like bacteria. So there was a lot of excitement. This meteorite, this stone, was supposed to have fallen from the Mars. Now, Mars, for a long time, had been kindling our hopes to find life in the extraterrestrial space. And so people were very excited. They thought that they have finally found an evidence of life on Mars. But unfortunately, I cannot go into details now for shortage of time. But in brief, these turned out to be an artifact because of processes in the treatment of the sample rather than actual bacteria. But that made a very, very interesting thing at that time. So we have had extraterrestrial material with us, not only from the Moon, which started in 1969, but even before that, we had recovered a lot of meteorites, and some of those meteorites seem to be having organic material. Once it was a contamination from the cigarette of the scientist who was studying it, but otherwise people hope that perhaps at some stage we will find a meteorite where we could see life. Because these meteorites could be coming from Mars, from Moon, from comets, from asteroidal belt, and so on. There have been some false signals. Like many years ago, people found an hourglass-like figure, a figure of 8 on the surface of Mars. And people thought that if this several kilometer huge 2 circles had been drawn on the surface of Mars, there must be some intelligent people living there. But then it turned out that they were not drawn, they were because of the glaciers on the surface of Mars. Similarly, people photographed in 1976 the Mars surface, and they found a skull there, which was about 3 kilometers in size. And later, when the second photograph was taken after 25 years in 2006, then people realized that this was actually a formation, a structure made of lava, and it was not sculptured by any living beings. So there have been false signals, there have been a lot of excitement, but there are evidences on the surface of Mars which show that water at one stage was flowing there. People have found minerals there, and those minerals cannot be found unless you have water on the surface there. There are craters there, there are old lakes there, and in the lakes you find the collection of sediments, just like you find on Earth, where there is a water reservoir. That means layer by layer deposition of sediments, which is an indication that there was water there and sedimentation took place, which makes a very clear conclusion that at some stage, maybe 1 billion years ago or more, there was water on Mars. You can see the same kind of sand dunes on the surface of Mars today, which you see in Rajasthan or in desert, which means at one stage, there were winds flowing on the surface of Mars. Now, even China has landed on Mars on 2021, this year in the month of May. They had landed a spacecraft there, a rover there, and that rover is moving there, and they're trying to collect the information about the surface material, the rocks there, what kind of elements are there, and so on. On Mars, people had also found some kind of berry-like structures, small spherical balls. Again, these spherical balls are formed on Earth if there are solid particles inside some liquid medium where there is dust and dirt, which accumulates around these nucleus or these particles, and these balls are formed. That means, again, a proof that there was water on Mars. So water was there, wind was there, there were streams of flowing water on Mars, because again, some channels have been seen and photographed on the surface of Mars. The minerals, as I said, the name of the mineral is goethite. That mineral goethite has been detected on a Mars surface, giving a very clear indication that at some stage there was water, because otherwise this mineral wouldn't have formed. But the question always is asked, what evidence should we take as conclusive to say that there is life on some planet? There is no definitive thing unless you go to the Mars and see a camel. Because jokingly, one scientist has suggested that we should send flea traps on Mars. We should set up some flea traps, that is traps which could detect or catch some kind of insects or moths on Mars. Somebody said, why do you expect fleas or moths or insects on Mars? He said, well, you see, there is a desert there. If you have a desert, there would be camels. And if there are camels, there would be droppings from the camel. And if you have droppings from the camel, there would be fleas. So we should send a flea trap there. But okay, jokes apart, people say that if there are living beings on a planet, we should be able to detect methane gas on that planet. I also told you that methane has been detected on Mars from the Mauna Kea telescope in the Hawaii Island. But now the problem is there is no way of knowing whether this methane originated from inside of the planet Mars, or this is because of any organic activity. Because inside the surface of Mars, there could be some processes going on in which methane can be released. So unless this is established that this methane is organic in origin, that is, it is because of bioactivity, we wouldn't be able to say that these are because of some life. Of course, these gases can be detected. Second thing is, I always feel, and perhaps some of us feel, that when we think about life, we always think in terms of a life form which has got 2 eyes, 1 nose, 2 ears, 1 head, 2 arms, 2 legs, and so on. Or it has got 4 legs, or it has got, you mean either it should resemble an animal or a human being. Now, why should it be like that? We have so many insects, we have so many bacteria which are very different from animals and living beings. If you go to the depths of the ocean, you would see living beings there, which would surprise you. I just show you a few photographs. You'd be surprised that this kind of life forms can be there. When we talk of vegetation on any other planets, we always think in terms of plants which have green leaves and brown stems. That's wrong. There could be life forms, there could be living things, because we consider life in the plants. So there could be things there which are very different from the vegetation on Earth. On Earth,
Chandra, I know it is very last moment, but now you have share screen option in case you wish to.
Okay, so what I'll do is I'll go a little back and just show you those color slides very quickly. And
this is interesting with the slides for sure.
Definitely. So I'll do that. Let's see. Try to share the screen. Yes, it looks now, it looks like it's possible. Share. Are you able to see something now?
Yes, we can see.
Okay. I'll start from where there are photographs and very quickly run through them. Can you see it now?
Oh, yes, we can see.
Okay. This is an artist's impression of the solar system. As you can see that there is the sun at the right end, and then we have planets from there. Sun is on the left-hand side. And then you have Mercury, Venus, Earth, Mars, asteroidal belt, followed by Jupiter, then Saturn, then Uranus, Neptune. Pluto is now out. And then you go very far away and you would see comets. This is Moon, our only satellite. This is Mercury. You would notice that the surface is cratered, which means this is bombarded by the particles. So even if there were life, it would be very difficult for life to survive. There is no atmosphere, no air, and the temperature is 450 degrees Celsius. If you go to Venus, it's enveloped in very, very poisonous gases like sulfuric acid, like ammonia, like carbon dioxide, and so on. So life doesn't seem to be a possibility there, especially because of the 460 plus degrees Celsius temperature there. Mars, again, has very little atmosphere, and that atmosphere too has very, very little amount of carbon dioxide and perhaps a little bit of methane. So no possibility of life, no water on the surface. This is the asteroid I talked about. This is an artist's impression of an asteroid, which is 140 kilometers big and made almost purely of nickel and iron. And this is the dada of the solar system. Jupiter, again, this is surrounded by this lot of gases, which is not oxygen, therefore cannot survive. There are Jovian satellites, that is satellites of Jupiter, many of them, dozens of them, but these are 4, and these are based on the impression. You have surface, this is one of the satellites. Surface features show that there is some kind of movement there, which is making this kinds of signatures. This is Uranus. This is a bluish color because of the gas there, which is dominated by hydrogen. This is also very huge, but very cold. This is one of the satellites of this Titan's photograph. Hygiene probe being dropped on Titan, which is a satellite of Saturn. This is the artistic impression, not actually a photograph, but based on the inputs from the satellite observation. This is only 5,000 kilometers bigger than Moon. This is the surface of Titan, satellite of Saturn. You can see that the surface is uneven and rugged. This is Neptune, the farthest planet now. Again, only hydrogen and maybe a little bit of helium in the atmosphere. This is again huge, about 50,000 kilometers in diameter, but very cold. But this is one moon of Saturn, which is different from many other satellites. And you could see that there are spray of waters from its lower hemisphere. These are warmer than the surface of the satellite. They come out with a velocity of almost half a kilometer per second, which is pretty fast. And they are saline. They contain nanosilica particles. How nanoparticles are generated, we do not know. This is the house of Mr. Reddy in New Jersey in the USA. A satellite meteorite fell from the surface, broke it, and fell in front of him. Moon samples came in 1969, but before that we had huge bodies like this which fell on Earth. In fact, one American president had said, who would believe that stones fall from the sky? But they actually do. And they are something like 36.5 tons in mass. And some of them have not been moved in Africa. There is one in Southwest Africa, there is a satellite called Hoba, which is 60 tons in weight. So it just lies there for the last decades, many decades. It has not been possible to move it from there. So the museum had been made around that. And this is another satellite. You could see this is very huge, taller than a very tall man. And this is the kind of impact effect of these asteroids. When it falls, in Arizona it fell, and it created a crater which is almost 1 kilometer in diameter, more than 1 kilometer in diameter. This is known as the Ninja crater. And you could see that if something like this falls on Earth, what would happen? And in fact, people believe this happened 6.5 crore years ago. 65 million years ago, an asteroid like this fell from the space somewhere in the Pacific Ocean. It created a crater which is known as Shiva crater, this near Mexico. And this was the reason why dinosaurs became extinct. Because the dust and everything which came out perhaps completely stopped the sunlight from reaching Earth. Therefore, the vegetation died gradually because there was no photosynthesis. Vegetation died, and because of vegetation died, whatever animals were there, they also died. And when animals died, even the even those animals which were carnivorous, which ate these animals, their food web was also broken, so they also died. And this kind of thing, people believe, brought the end to the most mighty creatures which ruled Earth from almost 150 billion years back, almost 65 billion years back. Almost for 9 crore years, these giant dinosaurs dominated Earth. And many of them were vegetarian, some of them were not. But the end came because of perhaps a body like this falling on Earth. But our atmosphere saves Earth from many such bodies unless they happen to be very huge. These are some of the meteorites which fell on Earth and which are believed to have come from Mars. This is the figure of 8 on the surface of Mars, which I had mentioned. And people thought that this has been carved by some intelligent beings there. But then it turned out that this is because of that small hill you see at the back. There was ice on top of that hill. And when temperature increased, that ice melted, came down and formed a small circle like this there, like a glacier. And then it again came down to maybe half a kilometer deeper and again formed this kind of figure. So many things which we see as features on other planets are not necessarily because of some living beings. They may be natural features like this. There is another far more interesting feature, this sculpture on the surface of Mars. This was taken in 1976. And 30 years after that, when another spacecraft went, it took the photograph from this angle and it realized that this was a geological formation. It was a lava dome. It was made from lava, and this had not been sculpted by any intelligent being. So people know that, okay, they lost hope that they could find life on Mars. This is again, an actual photograph. It is almost a 3 kilometer by 3 kilometer feature, but when photographed from a particular angle, it appears like a human face. These are streaks of water on Mars, which showed that at some time, water was flowing on the surface of Mars. These are some of the missions which went to Mars. Sojourner, it was in 1997. It landed on Mars. It was a small, very, very experimental rover. It was there on the surface of Mars. Then in 2004, Spirit and Opportunity, 2 more rovers landed there, and they sent us really very valuable information. They were quite heavy, almost 150 kilograms in weight. They moved on the surface of Mars, entered the craters, climbed up the craters, and then gradually they kept sending us information for decades. And finally, they were written off. Curiosity, it was in 2012, rather recently. Perseverance, which landed on the surface of Mars this year in the month of February. And its main function, main aim is to look for signs of past and present life. Of course, finding present life is not going to be easy, but it will perhaps look for signs of water or evidence of water and so on. Then there is another Chinese rover now on the surface of Mars. It landed there on May 14th. This is known as Zhurong, and this is continues to explore the surface. Now, you see, these are the features which you find on the sides of the lakes. And this shows that there was water, there was mud or dispersed in water, which gradually sedimented. These are blueberries observed by the Opportunity rover on the surface of Mars, which showed that there was water here. These are the sand dunes. On the left bottom, you see the terrestrial desert. And at the right top, you see the sand dunes on the surface of Mars, which means there were winds blowing here. There is a goethite mineral found on Earth. This can only form if there is water, and it has been detected using a special instrument. It has been detected on Mars surface. This is, you see at the bottom picture, there is a bacteria-like feature. Can you see that? In the left triangle of the picture, there is a bacteria-like multicellular object there. And Americans claim that this was a bacteria. But later, for many scientific reasons, based on oxygen isotopes, based on their size, based on the contamination possibility, they said that this was not a meteorite, but this had generated tremendous curiosity all over the world. And Bill Clinton came to the television talking about this. Now, this is why do we always expect green plants? Plants could be red, because it's not always necessary that we should only have the pigment chlorophyll, which is formed because of photosynthesis. There could be other kinds of reaction happening. Another thing we must remember, we should be looking for life forms which are similar to us or the familiar life forms. You know that there are animals, there are fish. When the temperature goes down, below zero, there are sea animals or lake animals which produce a particular kind of protein. That protein does not allow their blood to freeze. Therefore, even when the temperature goes very low, they don't die out. They continue to live because of that anti-freeze protein their body has been producing. Polar fish are known. They make anti-freeze proteins. Therefore, even at temperature which is below 0 degrees centigrade, they just go dormant. And when the temperature is favorable, they stop producing that protein and they're fine. This is an animal form, a few millimeters in size, found inside the ocean at a depth of several kilometers. At those depths where light doesn't reach, where there is no oxygen, how do these animals survive? We don't know. These metazoans, or they're called Loricifera. These animals have been observed by people some 10 years ago. And earlier people thought that under those conditions, only virus can survive and bacteria or small animals cannot survive. It means the force of life is strong. Even in planets like Mars or some other planets, maybe there are life forms which we cannot imagine. This is a sea sapphire at a particular angle inside the ocean. If you look at it, it has a chitin layer. And below that it has crystals. Now those crystals are very strange crystals. At a particular angle, they stop reflecting any light, and we cannot see that at all. So sometimes they become invisible. They also keep changing their color. So such strange life forms are there which we are not familiar with. If you go to the Antarctica, there you would find bacteria. There is a Violence Lake in Antarctica. People collected samples from there at 0.8 kilometer depth, at 3.4 kilometer depth, and 3.7 kilometer depth. And those bacteria could be brought to the laboratory, and then they could be cultured. Similar bacteria could be grown from them, which means they were live under such unfavorable conditions. So I think we should expect that we are not the only one life. We cannot see life at present in any planet or satellite other than Earth, but there could be life, because as Carl Sagan said, civilizations either became spacefaring or they became extinct. And as I said earlier, either they're not interested in us, we don't interest us, or we are not capable of seeing their signals, or they're too advanced, they just don't care for us. But in this huge cosmos, where there are billions of galaxies, and each galaxy has billions of stars, each star, many of them could be having planets, and many of those planets could be at the right distance from the sun. In other words, those planets could be inhabitable planet. So at least in some of those planets, life would have survived. Because after all, we should not be too proud. And as Carl Sagan said, who are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy, tucked away in some forgotten corner of a universe in which there are far more galaxies than the people we have on Earth, which are just 6.8 billion. And the number of galaxies is more than that. And in each galaxy, the number of stars is more than that. Therefore, the search for life must continue, because this is always a win-win situation. If we find the extraterrestrial life, it's mission successful. If it won't prove it, then we can always say, okay, we are unique. There is no one like us anywhere else in the universe. Thank you very much. Thank you.
This was really interesting, and I'm sure many of us have questions post this interesting session shared by you. I wish I could have also learned about astronomy, and I wish I could go back to my study days and start again. Very, very interesting session. May I request Poonamdi to take up the question answer session with both our speaker. So Dr. Poonam Arora has retired from a long academic career in the humanities at institutions in the US, Middle East, and India. She has turned her attention to the larger questions of peace, social responsibility, and activism over the past few years. Her training in literature, film, and cultural studies now seeks to address real-life psychological, political, and artistic domains to elevate our collective quality of life. So that is Dr. Poonam Arora for us. Poonam Arora ji, over to you for taking up question answer sessions.
Thank you, Jane. Dr. Nautiyal began by saying that he's going to perform a Madari's trick, and I'm going to perform another Madari's trick. He may be a Madari coming from science disciplines. I'm a Madari coming from the humanities and social sciences. And what I'm going to say are not really questions, but really provocative further discussions or imaginative leaps that we can take from this talk most recently, and then I'll go back to the first talk. So as a humanities person, I want to put the following three concepts under the spotlight. What is life? What is intelligence? And what is time? So even though Dr. Nautiyal ended by saying that we've had at least 50 years of space exploration and we've exhausted the possibilities probably of life in our solar system, but there are infinite opportunities elsewhere to look. So my question is, what exactly is he calling life? The first part of his talk was about the fact that the kinds of conditions we need for human life, water, air, gravity, sun, the size of our bodies compared to the size of the earth that we live on. This is what we call life on earth. I would say, let's consider what is life more generally. There could be life that is much bigger than us or much smaller than us. Again, to return to Carl Sagan, he said, as long as there are amino acids that can form the basis of life, we should not close the question on, is there life in the universe? And I want to say, I would say anything that is born, grows, and dies, that means it has a limited time span. I'm not saying a limited time span of 70 years or 80 years. Even if that lifespan is a few seconds or 1,000 years, we should call that life because it is bounded by a birth, a growth, and a decline. And then that decline is like a chain reaction. There should be more birth, more growth, and more decline. So that's what I'm calling life. What do we mean by intelligence? That this organism, no matter how big or small, growing under very different conditions of light, heat, gravity, whatever, has the ability to evolve. has the ability to collectively, not one individual life, but as a species, it has the ability to progress. This is what I call intelligence. And time. This is very important from a humanities point of view because we are thinking of life contemporaneously. That means, is there life today on Mars? Is there life within the lifespan of our civilization? But we haven't considered that there might have been life previous to our civilization and in different time eras. So let's say there was life 50 million years ago, and they sent us messages that are coming at a certain speed, which has either reached us before we evolved or will reach us after the civilization has ended. So these are some very, very important questions that we must frame the conversation with in order to expand its boundary. I have no disagreement with what Dr. Nautiyal has said. It was brilliant, very interesting, stimulating, etc. I just want to expand the reach of our conversation. So maybe, I mean, there are instruments installed in New Mexico, among other places in the US, from where we are sending radioactive signals to other civilizations so that they might catch us or that we might receive those signals. The question is, when were those signals sent and how long will it take for our signals to get there? And those signals that may have been received on the Earth may have come to this Earth before this civilization or this form of life called the human, with its current intelligence, was prevalent and had the intelligence to receive and interpret the signals that were sent. So there are lots of variables to which we can attach these questions. There is also the question of electromagnetic forces. We can send signals in past time and we can send signals to future time. It's just that within the span of our 70 or 80 years, we should not expect that these signals will be received and reciprocated. So these are some complicating issues. I found that between the two talks, the question of water is very important. We seem to believe that life needs water, and if there's no water, life is not possible. I want to suggest that some of the crises or some of the problems that Dr. Narela pointed out also connect to water. So for instance, he said that our current climate change crisis, and some will disagree with me that this is a crisis, but let's go with the current climate change crisis is because of our inability to manage water efficiently. So he talked about, the disposal of waste, the waste running through water and being deposited into bodies of water. As some of you know, I've spent maybe 2/3 of my life in the US. I've only just returned to India, and even living in a very affluent part of Delhi, I am very shocked and surprised and dismayed at the very elementary level at which our basic utilities, like for instance, the sewage system, is working. I would say this notion that we should transport our waste and through a centralized connected sewage system that goes from one house to the river nearby or the lake nearby is a very, very flawed system. as the speaker hinted, we should really rethink this whole process, because our drinking water and our sewage system are both reliant on water. Even though we have a huge shortage of water and it's becoming worse, we have somehow attached our drinking water problem and our sewage disposal problem both to the flow of water. And this is a colossal mistake. When the present government said, we will provide toilets for everybody, there should be toilets so that we don't excrete waste out in the open, the government also made the commitment that this sewage system or this toilet system will be connected through a water flowing sewage system that will connect one toilet to the next toilet to the next toilet and eventually into the river. And then at the river level, we will have to clean that water to bring it back as drinking water. What we need to think about, if we are to attack just one issue out of a myriad issues that is contributing to climate change, we have to rethink our sewage system, not based on water, but dry sewage system. And as the speaker said, we need to be able to deal with it as a private treatment system rather than a government facility that is available only in urban centers. This to me was a very provocative idea, and not that I want to flatter myself, but something I've been thinking about, that we are making the situation worse before we can make it better. We should first be connecting all urban and newly urbanizing centers to a sewage system. And then we find that the sewage system breaks down, that it is inadequate, that it calls for infrastructure, that it calls for facilities for purifying water or transporting it. And then what happens when it reaches a river or the sea for that matter? We're polluting the sea in ways that we cannot reverse. I lived in the UAE, and the only source of fresh water in cities like Abu Dhabi and Muscat and Dubai is that they take seawater and they desalinate it and make it into drinking water, and then they throw the salt that is derived from this process back into the sea, making it more salty. So when we think about climate change, we should not just be thinking about, okay, what are the emissions from carbon, but what are the mistakes that we are making as we speak in addressing these problems? How can we reverse some of our processes in order to address a very, very, very large problem of climate change? The second perspective that I have on climate change is that measuring climate change has become the emphasis rather than reversing climate change. I understand that we need to measure so that we know what are the emissions like, when will we be carbon neutral, will it be 2050 or will it be 2060? Is Saudi Arabia justified in saying that it will reach the same goals as everybody else, but only 10 years later? Measuring what we will reach has become the emphasis rather than putting our finger on what exactly is going wrong. From a humanities point of view, for instance, I want to say that all the scientific advances that we have made in the last 200 years are predicated on the conquest of nature, not the conservation of nature. So we've built dams, we've made electricity, we've created transport. Everything is based on our notion of how can we conquer nature, not how can we live with nature and how can we conserve nature. We're past time, and I will just suspend these questions in midair so that those of us who are interested in these issues can ponder over this, and perhaps we will return to these very, very large questions of climate change and life in the cosmos again, and take up these questions further with greater detail and greater clarity. I'll end here. Thank you.
Thank you so much, Poonamdi. Do we have any questions for our speaker? Maybe we can take 5 minutes for any questions that we have, and then we will proceed toward the end of the session. Okay. Fine. So let's let's invite Arundhati for playing the video and of XENA family. And by the time she prepares for the video, we can actually honor our speakers and we thank them for enlightening us with such a intense topic. So thank you so much, Dr. Chandra, Santosh Kumarji, Dr. Sanjay. We were really honored to hear such topics and interesting perspective about this new thing that probably we can do for our Earth. There are many things that goes in our mind when we talk about Earth and how we can actually preserve the Earth. But throwing light through technology, through scientific perspectives gives us a new way of thinking. And Dr. Chandra, I really like the background in your photograph. It makes me think how much we love Earth, and there's nothing as beautiful as Earth. So thank you so much for such a wonderful topic. We are really, really thankful to all of you. Thank you, Poonamdi, for the speech that you gave to us. May I request Arundhati ji now to play the video?
सदस्य जीनत है जीना परिवार हमारा, चारों ओर खुशी फैलाने का है अपना नारा। हम सदस्य जीनत है जीना परिवार हमारा, चारों ओर खुशी फैलाने का है अपना नारा। कष्ट गरीबी दुख हरने का हम संकल्प उठाएं, धरती को कुटुंब करने के लिए प्रयास बढ़ाएं। कष्ट गरीबी दुख हरने का हम संकल्प उठाएं, धरती को कुटुंब करने के लिए प्रयास बढ़ाएं। हम सदस्य जीना के है जीना परिवार हमारा, चारों ओर खुशी फैलाने का है अपना नारा। सबको रोजी रोटी हो और सबको हो खुशहाली, हो निर्बाध विचार भावना सदा सीखने वाली। सबको रोजी रोटी हो और सबको हो खुशहाली, हो निर्बाध विचार भावना सदा सीखने वाली। हम सदस्य जीना के है जीना परिवार हमारा, चारों ओर खुशी फैलाने का है अपना नारा। दया क्षमा नैतिकता हो और हो सम्मान सभी का, सबको यूं अपना माने के दिल ना दुखे किसी का। दया क्षमा नैतिकता हो और हो सम्मान सभी का, सबको यूं अपना माने के दिल ना दुखे किसी का। हम सदस्य जीना के है जीना परिवार हमारा, चारों ओर खुशी फैलाने का है अपना नारा। हम सदस्य जीना के हैं, जीना परिवार हमारा, चारों ओर खुशी फैलाने का है अपना